Hi, and welcome to another end of chapter in measurement. I am Ryan Reddy,
I am Muhammad Shazani.
and we will present you on how we do our testing on an oscilloscope. So, this is our overview on the steps to use an oscilloscope. There are four steps, that is calibration, connection to the function generator, find the specific waveform, and the calculation.
This is an oscilloscope, a device that allows the amplitude of the electrical signal as a function of the time. Calibration. To check calibration oscilloscope, step 1. Switch on the OSC. 2. Put the probe to the input. 3. Touch the hook tip to the CL and crocodile clip to the ground. 4. Make sure the selection mode same with the input. 5. Select vol per division, same with the value at CL. 6. Select time per division, 0.5 millisecond. It will get F equal 1 kilohertz. 7. At the screen, the waveform appear is square wave. This is a example connection for calibrate oscilloscope. After do a connection for calibrate oscilloscope, check the shape of the display waveform. Calibration must be square wave, just like the picture is correctly compensated. Vol per division depend on value of CL on oscilloscope. For the time per division must be 0.5 millisecond to get frequency equal 1 kilohertz. A poorly adjusted probe can make your measurements less accurate. The figures show what happened to measure waveform when using a probe not properly compensated. It can be correctly compensated, overcompensated, and undercompensated. Next is connection to the function generator. This is a basic function of signal generator. From panel of a signal generator, this is a frequency selection group. This is a waveform group. This is a output group. This is a amplitude modulation group. And this is a DC offset group. This is how to connecting the function generator to the oscilloscope. Connect the alligator clip of the black lead from the function generator to the alligator clip of the black lead from the oscilloscope. After that, do the same with the red lead. This is example a block diagram of the connection between the oscilloscope and signal generator is simple.
And to that, up next is finding the specific waveform. So, to find the specific waveform, we must first know the function in function button group. The first one is the power switch. This is obviously known to everyone. Same goes for the second one, that is power on indicator. The third one, frequency selection group, consists of frequency range and frequency selector. Frequency range is to set the frequency required. Frequency selector is time the value of the frequency range with the frequency selector to get the frequency required. To get the desired frequency, frequency selector must be multiplied with frequency range. Up next, the fourth one, that is amplitude modulation group, consists of amplitude knob, that is to increase the amplitude of signal this button should be adjusted. Turn clockwise to increase the value and anti-clockwise to decrease the value. The fifth one, waveform group, consists of waveform selector. That is to choose type of waveforms, either sine wave, rectangular wave, or triangle. The sixth one, DC offset group, consists of offset adjustant. An offset is control to provide to allow the DC level of the output waveform to be set as desired. Duty control is to symmetry the output waveforms. The seventh one, waveform group, consists of waveform selector. It is the same goes for the fifth one, but works in a different way. It is the same type of choosing a waveform on either sine wave, rectangular wave, or triangle wave. The eighth one, output group, consists of output 50 ohm, square wave, triangle wave, sine wave, ramp, and pulse. Waveform is provided. Use BNC connectors. The ninth and last one can only be found in digital function generator, that is sweep group. Sweep group is used to set the frequency output. It could be swept up or down in frequency using linear or log sweeps. And lastly, the last step is the calculation. So before making the calculation, there are measurement techniques. The major concern in observing a signal on the oscilloscope screen is to make voltage and time measurement. The oscilloscope screen is partitioned into the grids, which divides both the horizontal axis, that is voltage, and the vertical axis, that is time, into divisions which will be helpful in the making of the measurements. As you can see here, the vertical axis, that is the y-axis, which is the volts, and horizontal axis, or the x-axis, is time. You can see here on the oscilloscope screen, the graticule is a grid of lines that serve as a scale when making time and amplitude measurements with an oscilloscope. Voltage and time is determined by using grids on the display. Each square on the grid is called a division. So, you can see what I meant on this example. Frequency and time measurement. Time measurements using the horizontal scale of the oscilloscope. Frequency. Oscilloscope can measure frequency through measuring time. The frequency is given by the reciprocal of time period, which is 1 divided by t. And this is how you measure time and frequency. Frequency is equal to 1 divided by t, and time is equal number of division times time per div. And if everything goes as the steps shown above, you will get the result as shown on figure 1. And now we need to find our frequency. But before doing that, we don't know our t or time. So by using the formula and finding the number of division on the oscilloscope screen, we got 3.7 times 5 milliseconds. We got our answer, that is 0.0185 milliseconds. And now we know our answer to t. We can find our frequency. 1 divided by 0.0185 milliseconds, we got 54 Hertz. And so we reach our end of our presentation. Thank you very much for watching our video, and I hope you learn a thing or two in this video. Thank you very much.